Hello, my name is Gurveer Singh Virk. I'm from the team Prometheans. Our product statement is to develop an autonomous mobile manipulator with ROS and SLAM technology for planetary exploration. Our objectives are to develop an autonomous rover equipped with a robotic arm and incorporate a vision system for navigation and object detection. The rover is designed as a six-wheel drive platform with skid steering and improved suspension for durability and all-weather and all-terrain capability. These are the various components of the rover that we are creating. The most important one is the Pixar. It is a flight controller which runs the Pixar firmware as well as the autopilot software, which is installed from the Mission Planner GCS as shown here. The robotic arm has 6 degrees of freedom and is powered by 6 servo motors. It is designed as for pick and place operations. This is a picture of the robotic arm that we are going to use in our project. The Jetson Nano is the brain of the entire operations. In case of the rover, it will act as a companion computer running Mavros as a communication interface to send commands and messages to the Pixar for carrying out missions. In case of the robotic arm, we'll be running multiple packages and applications for robotic visualization, movement, and simulation. ROS, as mentioned before, stands for Robot Operating System. It mainly consists of nodes, topics, and services, and its methodology of working is shown in this figure over here. Mavros is basically ROS is Mavlink. The vision system includes a camera alongside a LiDAR sensor. We'll be using SLAM techniques such as Google Cartographer to generate a 3D map of the environment for path planning and obstacle avoidance. These are the various applications of a project. These are from the space side and will basically enable us to do operations and missions, which will be difficult for us to do due to the harsh environments on other planets. So to be able to plan missions for the robotic arm, I first got a CAD file and then create partitions for the different parts of the arm. I then gave it a link before after setting a forward type as visual and then creating correlation objects for all the parts. After that, a motor and a controller was added for all the joints of the robotic arm. The mask is set for all the parts, and these are just placeholders. All of this basically mimics a URDF file structure with the Phobos type and links. After that, the file is then exported using this part of the Phobos add-on right here, and the meshes are exported as DAE files. This is done on Blender 2.79. The URDF files are then used in the Movie Setup Assistant. We launched this using this command right here. We then load the URDF file into the Setup Assistant and follow these steps or the tabs provided here. This basically helps us create the planning groups, the robot poses, the end effectors, the controllers for the particular planning groups in the correct manner, the actuators, the transmissions from the for the URDF file, etc. And then lastly create the package itself. This package can then be used by this command right here. This launches a demo file, a demo RS instance, which can be seen right here. Right now, I've launched the robot model in the RVS as well as launched a GUI to move the sample robot around. This helps me move it around and get the particular orientation I want it to be in, which will be useful in planning out missions and creating operations. This can then be converted into PWM signals using a simple Python script by using the join states that are created from the GUI. That's it. So we're currently working on integrating the cartographer ROS package as well as the RP LiDAR with the rover for better navigation and object detection. We'll also be integrating the a camera onto the rover for the same reason, and covering the rover properly for a better look as well as for better protection. That's it. Thank you.